Okay, now I calculated this. I did this calculation in my head. I think I got it right, but you might want to check me out. I think that we get y is 1.1042 approximately. I think more accurately it might be 104.1 and then 6 repeating. So if I got that right, okay, sometimes I do. You can check that out with your calculator. Very easy to plug this in. Okay, now, why should this be different than this? Well, let's go back to the original graph. Our graph curves. Our tangent line is straight. Our tangent line and our graph agree right here. However, the graph, the way it curves, it's going to curve down below the tangent line. Now the graph represents the accurate value, the value that we get if we actually plug this number in here. And since the square root of 121 is 11, since 11 squared is 121, the square root of 1.21 turns out to be 1.1. So if we project from this point up to the graph and then back over to the axis with this white projection line, we get to the point on the axis where y equals 1.1. We have to, because this is a graph of y equals square root of x, and the square root of 1.21 is 1.1. Okay? Now, if we follow the tangent line down to the point right above x equals 1.21, we get this value. And we can see that if we come up to the tangent line and over here, since the graph curves down below the tangent line, we're going to get a number a little higher. And sure enough, this number is a little higher than this number. And that number I've written in green over here. Kind of small, might be a little hard to read, but there's my 1.1042, which is a round off to 5 significant figures, if I calculated correctly, and I think it's fairly plausible. So we see that there's a difference. It's a small difference, and actually the graph has exaggerated that difference. It's not as big as it looks, because the difference is only 0.0042, 4 parts in 1,000, 1 part in 250 of 1, and let's not worry about that. It's a smaller difference than it looks like here. If you actually graphed it accurately, there'd be a very tiny difference. But we want to notice a couple of things. We want to notice that the further we get from this point, the further the tangent line gets from the actual graph, because of the way the graph is curving. But it stays pretty darn close for quite a ways, because this is 1.21, 36/25 is 1.44. That's a pretty big gap there. And over that whole gap, the tangent line is very close to the graph. And it's even closer on this side, because the curvature of the tangent line keeps decreasing. So the tangent line can be useful as an approximation to any function, as long as we have a good handle on how far the tangent line will deviate from the function over a given range, or given domain, a given interval. Now that's in the future, but that's just one reason. You don't have to completely digest what I just said, but the tangent line gives us a useful approximation in the neighborhood of the point of tangency. And how big a neighborhood depends a lot on characteristics of the function that we'll analyze over quite a long period. Okay, it's going to take us a while to develop all the skills we need to do that. And here's another depiction. Again, I've even further exaggerated this difference. It's much smaller than it looks. But here's our 1.44 on the horizontal axis. Here's our 1.21. Here's our curve, and here's our tangent line. Now the tangent line is just a little too high here, but we can see how the curve and the tangent line, how the tangent line diverges from the curve. Okay, how the approximation we would get if we use the tangent line moves away. It gets worse and worse as we move away from the point of tangency.